Hello, and welcome to Physics at Night. I am so glad you're here. Whether you're lying down in bed with the lights dimmed low, slowly melting into your pillow, or curled on the couch, letting your mind float like a leaf on still water, this space is for you. Tonight, we're going to travel to the quietest places in the universe. We're going to visit the objects that cast the longest shadows. We're going to talk about black holes, but not the monsters you see in movies. We're not going to talk about destruction. We're not going to talk about danger. We're going to talk about silence. We're going to talk about gravity so deep and so profound that it creates a permanent hug around the fabric of space. We're going to explore what happens when the universe decides to keep a secret. We will drift toward the event horizon, the edge where the known world ends. We will ask what it feels like to cross that line. We will wonder about the geometry of the dark, and whether the center is an end or a beginning. Now, I should gently warn you, this journey goes very deep. It may soothe you so well you won't hear the end, but if it keeps your mind glowing a bit too long, I promise that even wakefulness can be restful when filled with wonder. If you find peace in this moment, I'd be grateful if you gave this video a quiet like, and maybe subscribe for more dreamy science. And if you're comfortable, I'd love to know where you're listening from and what time it is there. Your words light up a map of bedtime from around the world, a constellation of rest. As always, this story is for relaxation and gentle education only. It is not a substitute for medical advice or professional care, just a safe harbour to fall asleep with curiosity. Now, let's begin. Imagine you are drifting in deep space, far away from the noise of the earth, far away from the heat of the sun. The silence here is perfect. The darkness is absolute, except for the distant glittering dust of the Milky Way. You're safe. You are warm. You're simply observing. Ahead of you, there is a patch of sky where no stars shine. A perfect circle of emptiness. It doesn't look violent. It looks calm. It looks like a lens, bending the light of the galaxy around it into a beautiful glowing halo. This is where we are going tonight. We're going to approach the edge. We're going to look into the well, and we're going to discover that a black hole is not a vacuum cleaner. It is a waterfall. It is a place where space itself flows like water, and time flows like honey. So take a deep breath. Drop your shoulders, let the gravity of your own bed hold you, and let's drift toward the horizon. Enough thinking. Let's begin by leaving the earth behind. I want you to imagine that we have slipped the surly bonds of gravity. We have drifted up through the clouds, past the moon, past the planets, and out into the deep velvet silence of interstellar space. You are floating in a small, comfortable capsule. The windows are wide and clear. Inside, the air is warm. There is a soft hum of life support, like the sound of a fan in a summer room. But outside, there is only the absolute stillness of the void. You're far away from any star. The sun is just one bright dot among millions behind you. Here, the universe feels empty. But it is not empty. It is waiting. We are drifting toward a specific coordinate in the constellation of Cygnus. We're looking for something that cannot be seen with the eyes, yet it is the most powerful object in the sky. We're looking for a black hole. Now, I know that for many of us, the words black hole trigger a feeling of anxiety. We have been trained by Hollywood movies to see them as monsters. We imagine violent swirls of fire. We imagine tearing metal and screaming sirens. We imagine a cosmic vacuum cleaner that wanders around the universe, angrily eating planets. But tonight, I want you to unlearn that picture. The universe of the movies is loud and messy. The real universe is quiet and precise. A black hole sitting alone in the dark is not a monster. It is a geometric shape. It is a sphere of silence. It is a place where the fabric of the universe has settled into a deep, permanent rest. As we drift closer, let's say we're about 1,000,000 miles away, we begin to see it. Or rather, we see around it. Imagine a perfect black circle cut out of the starry sky. It is absolute darkness, Vanta black, a hole in the tapestry of the night. But around the edge of this circle, something magical is happening. The light from the stars behind the hole is not blocked. It is bent. The gravity of the object is acting. Like a giant spherical glass lens. You see the starlight curving around the darkness. The stars look smeared, stretched into long, elegant arcs. It looks like a bubble of oil floating in water, refracting the light of the galaxy into a halo. This is called an Einstein ring. It is a rainbow of gravity. It is stunningly beautiful. It looks peaceful. It looks like an eye, unblinking, watching the cosmos. As we float closer, you might expect to feel a pull. You might expect your ship to rattle, or to feel a heaviness pressing you into your seat. After all, this object weighs 10 times as much as our sun. The gravity here is fierce. But you feel nothing. You feel perfectly weightless. You're floating in your chair. Your pen is floating next to your hand. It feels exactly like drifting in deep space. Why? This is one of the most profound secrets of physics. It is what Albert Einstein called the happiest thought of my life. Falling is indistinguishable from floating. When you're in orbit, or when you're falling toward a massive object, you're surrendering to gravity. You're letting it take you, because you're not fighting it. You don't feel it. Gravity only feels heavy when you resist it, like when you stand on the floor. The floor pushes up and you feel weight, but here, in the vacuum, there is no floor, there is no resistance, there is only the slide. I want you to visualize the space around us not as empty vacuum, but as a river. Imagine the fabric of space-time as a clear, smooth liquid. Far away from the hole, the water is still, but as we get closer, the water starts to flow. Gravity is simply the universe flowing toward the drain. Right now, our capsule is a leaf floating on this river. We are moving toward the hole, picking up speed, carried by the current of space itself. Because the ship and your body are moving at the exact same speed as the water, you feel no motion. It is smooth. It is silent. We're sliding down the invisible slope of the universe, and as we slide, the view changes. The black circle grows larger. It starts to dominate the view. The stars are pushed to the edges of your vision. You're looking into the abyss. But it doesn't feel like a threat. It feels like a mystery. Think about what this object represents. In the rest of the universe, things are happening. Stars are burning hydrogen into helium. Planets are weathering storms. Galaxies are colliding. The arrow of time is marching forward, changing things, breaking things, building things. But inside that black circle, history has stopped. Whatever fell in there 1 billion years ago is still there. The light that was trapped during the age of the dinosaur is still there. It is a vault. It is a cosmic museum where the exhibits are locked away forever. There is a strange comfort in that. In a universe of impermanence, The black hole is permanent. It is the only thing that will survive the end of time, long after the stars have burned out and the galaxies have drifted apart. The black holes will remain, silent sentinels in the dark. So, as we hover here, just outside the danger zone, I want you to appreciate the calm. We are safe. Our engines are strong. We can turn around and power away at any moment. We are simply visitors standing at the edge of the Grand Canyon, peering over the rim. We are looking at the edge of reality. That line, the border between the starlight and the blackness, is called the event horizon. It is the point of no return. It is the place where the river speeds up to the speed of light. But from where we are sitting, it just looks like a shadow. A quiet, round, perfect shadow. So, take a deep breath. Let go of the fear of the dark. Darkness is just a canvas. We have approached the castle. Now, we must ask what lies inside. We must ask what this structure actually is. Is it a solid ball? Is it a hole in the floor? Is it a tunnel? In the next chapter, we're going to turn on our scanners. We're going to look past the illusion of the hole. We're going to define the geometry of the deep. But for now, just float. Feel the weightlessness of the fall. You're held by the gravity of the largest thing nature can build. We parked our spaceship 1,000,000 miles away from the shadow. We looked at the silent, perfect circle of darkness hanging in the star field. We admired the way it bent the light of the galaxy into a halo. But looking is not the same as understanding. Our eyes tell us we're looking at a hole. Our language tells us we're looking at a hole. Even the name, black hole, suggests a drain, a puncture, an empty cave in the middle of the night. But tonight, we're going to close our eyes and look with our minds. We're going to dismantle the name. We're going to find out that a black hole is not a hole at all, and it is not really an object in the way a planet or a star is an object. It is something much stranger. It is a region. It is a condition. It is a memory of gravity. To understand what this means, I want you to perform a thought experiment with me. I want you to imagine the Earth. Think of the planet we are sleeping on right now. It is a giant ball of rock and iron, 8,000 miles wide. It has a lot of gravity. It is holding the moon in orbit. It is holding the atmosphere down. It is holding you to your bed. Now, imagine we have a giant cosmic trash compactor. We take the Earth and we start to squeeze it. We don't remove any rocks. We don't take away any mass. We just push it closer together. We squeeze it until it is half its size, then a quarter. What happens to the gravity? From a distance, say, from the moon, nothing changes. The moon doesn't care if the Earth is big or small. It only cares about the total mass. The mass is the same, so the moon stays in its orbit. But on the surface of the shrinking Earth, things are getting intense. Gravity gets stronger the closer you get to the centre. As the surface moves inward, the pull at your feet multiplies. We keep squeezing. We squeeze the entire Earth until it is the size of a house, then the size of a basketball, then the size of a marble, and finally the size of a peanut. Stop there. You now have the entire mass of the planet, every mountain, every ocean, every city, crushed into a sphere about 1 centimetre wide. The density is unimaginable. But the physics is simple. If you were to stand on the surface of this peanut, the gravity would be trillions of times stronger than it is now. If you tried to jump, you couldn't. If you shined a flashlight upward, the light would struggle to climb. the beam would rise up, slow down, stop, and fall back down to the ground like a stone. This is the threshold. When gravity is so strong that even light falls back down, you have created a black hole. But here is the crucial part. The black hole is not the peanut. The peanut is just the mass. The black hole is the sphere of darkness surrounding the peanut. It is the region of space where the escape velocity exceeds the speed of light. Think of it like a fortress. In the center, there is the king, the mass. But the walls of the fortress extend far, far out. Everything inside those walls is the black hole. So, when we look at that dark circle in the sky, we are not looking at a solid surface. There is no ground to land on. There is no crust. We are looking at a shadow cast by a geometry that has gone rogue. This brings us to the second way of seeing it, the Care space-time view. In our previous sleep stories, we talked about space-time being a fabric, a rubber sheet. We said that stars are like bowling balls sitting on the sheet. They make a dimple, a funnel. Now, think about our crushed Earth peanut. It is incredibly small, but incredibly heavy. If you drop it on the rubber sheet, it doesn't just make a dimple. It is like sticking a pin into the fabric. It concentrates all that weight into such a tiny point that the fabric stretches downward endlessly. It pinches. The bottom of the funnel drops out. The curve becomes a cliff. So, a black hole is a place where the fabric of the universe has been stretched to infinity. It is a knot in the weave of reality. And this leads to the most ghostly realization of all. We call it a black hole because of what falls in. But we should really think about what is left out. Imagine the star that created this hole. It was a giant burning sun. It lived for millions of years. Then it collapsed. We will talk about how in the next chapter. The matter of the star fell into the center and vanished. According to general relativity, the matter is crushed out of existence at the singularity. So, the star is gone. The matter is effectively gone from our observable universe, but the gravity remains. This is the Cheshire Cat effect. In Alice in Wonderland, the cat disappears, but its smile remains hanging in the air. A black hole is the gravitational smile of a dead star. The body of the star has left the building, but the curvature it created is so deep, so self-sustaining, that it doesn't snap back. The indentation in the pillow remains, even after the head is lifted. So what is a black hole? It is a fossil of gravity. It is a place where gravity has become so intense that it no longer needs matter to sustain itself. The energy of the curved space itself keeps the hole open. It is a self-fueling storm of geometry, and because it is made of geometry, it is incredibly simple. Think about the Earth. It has mountains, rivers, weather, biology, chemistry. It is messy. But a black hole, it has no mountains, it has no weather. It is perfectly smooth. It is the smoothest object in nature. Physicists have a saying, black holes have no hair. This means they have no complicating features. If you throw a television set into a black hole, and then you throw a grand piano in, and then a dictionary, the black hole doesn't care. It doesn't remember the shape of the piano or the words in the dictionary. It just gets a tiny bit heavier. It converts all that complexity into pure, simple, smooth mass. It is the ultimate eraser. It wipes the universe clean of disorder. So, as you lie there, visualizing this object, don't imagine a solid ball of black rock. Don't imagine a whirlpool of water. Imagine a place where the rules of here and there have twisted. Imagine a spherical door. On this side of the door, we have space and time. On the other side of the door, we have something else. It is a bubble of after. It is a region of the future that you can see from the present, but never visit. This is why it is quiet. This is why it is stable. It is not a machine that eats things. It is a room with the door locked from the inside, and tonight we are drifting just outside that door. We are safe. The universe is holding us in the gentle slope of the outer valley. But we have to ask a question. How does nature build such a thing? How do you crush a star? It seems impossible. Atoms are strong. They don't like to be squeezed. What kind of force could possibly be strong enough to break the back of physics and punch a hole in the sky? The answer lies in the life cycle of the stars themselves. It lies in the balance between fire and gravity. In the next chapter, we're going to watch a star die. We're going to watch the lights go out, and we are going to see the moment when the heavy heart of a sun collapses into the dark. But for now, rest in the knowledge that the whole is stable. It is not hunting you. It is just a memory, frozen in the dark. In the last chapter, we defined our destination. We learned that a black hole is not a monster, but a memory. It is a fossil of gravity left behind when a massive object leaves the universe. It is a region where the fabric of space is pinched into a knot, but knots don't just happen. The universe doesn't just decide to delete a piece of itself for no reason. Something has to push it. Something has to break it. Tonight, we are going to watch the construction of the abyss. We're going to witness the most dramatic event in nature, the death of a giant star. But we're going to watch it in slow motion. We're not going to focus on the explosion. We're going to focus on the collapse. We're going to focus on the quiet, desperate struggle of a star trying to stay alive and failing. To understand this struggle, you first have to understand what a star is. I want you to imagine the sun. It looks like a ball of fire, but fire is too small a word. The sun is a hydrogen bomb. It is a continuously exploding nuclear reactor, 1 million times the size of the Earth. Every second it converts 600 million tons of hydrogen into helium. The energy released is staggering. It is pure outward pressure. It wants to blow the star apart. So why doesn't it explode? Why doesn't the sun just scatter itself across the solar system in a cloud of gas? Because of the crush. The sun is heavy, incredibly heavy. All that gas has mass, and all that mass creates gravity. The gravity wants to pull the star inward. It wants to crush the sun down into a tiny ball. This is the great stalemate of the cosmos. Hydrostatic equilibrium. It is a tug of war. Gravity pulls in, fire pushes out, and for billions of years they are perfectly matched. The star is stable. It is a balanced equation. It shines. It gives life to planets. It is happy, but nothing lasts forever. The fuel is finite. The hydrogen tank eventually runs dry. For a star like our sun, the end is gentle. When it runs out of fuel, the outward push stops. Gravity wins. The sun will shrink. It will crush itself down into a dense glowing ember called a white dwarf. It will be about the size of the Earth. It will sit there, cooling, fading, slowly turning into a black rock over trillions of years. It will be a retired star. It won't be a black hole. It isn't heavy enough to punch through the floor. But there are other stars, the kings, the giants, stars that are 10, 20, 50 times heavier than the sun. Betelgeuse, Rigel, Antares. These stars live fast and they die young, and their death is not a retirement, it is a catastrophe. Let's watch one of these giants die Imagine a star 20 times the mass of the Sun. It has burned through its hydrogen, but because it is so heavy, the pressure in the centre is intense. When the hydrogen runs out, gravity squeezes the core so hard that it forces the helium to fuse. The star gets a second wind. It starts burning helium into carbon, then carbon into neon, then neon into oxygen, then oxygen into silicon. It is frantic. It is burning heavier and heavier fuels just to generate the heat needed to hold back the crushing weight of gravity. It is like burning the furniture to keep the house warm. Finally, it reaches the end of the line. It starts fusing silicon into iron. Iron is the poison pill of stellar physics. You cannot get energy out of fusing iron. It actually takes energy to fuse it. The moment the core turns to iron, the fire goes out. The outward push vanishes instantly, and gravity, which has been waiting patiently for 10 million years, suddenly has no opposition. The collapse happens in a fraction of a second. The iron core, a ball of metal the size of the Earth, collapses inward at 25% of the speed of light. It shrinks from 8,000 miles wide to 10 miles wide, in less time than it takes to blink. The outer layers of the star rush in to fill the gap. They crash into the core with unimaginable violence. They bounce off and they explode. This is a key supernova. For a few weeks, this single exploding star will outshine the entire galaxy. It will be brighter than 100 billion suns. It scatters gold, silver, and oxygen across the universe. It creates the stuff you are made of. But we're not interested in the explosion. We're interested in what is left behind. Look at the center of the cloud. The smoke clears, and there, in the heart of the ruin, is the core. If the star was heavy, but not too heavy, the core becomes a neutron star. This is a city-sized ball of neutrons. It is incredibly dense. A teaspoon weighs 1 billion tons, but it is solid. The neutrons are packed so tightly that they touch. They refuse to be squeezed any further. They push back against gravity. The collapse stops. The floor holds. But if the star was truly a monster, if the core left behind is more than about 3 times the mass of the Sun, then the neutrons are not strong enough. Even the fundamental particles of matter cannot withstand the weight. The floor breaks. This is the moment of formation. This is the birth of the black hole. I want you to visualize this moment. Imagine the ball of neutrons. It is dark, it is heavy, gravity is squeezing it, the neutrons groan, the pressure mounts, and then they give way. The ball shrinks, 10 miles wide, 5 miles wide, 1 mile wide. As it shrinks, the escape velocity on the surface skyrockets, 100,000 miles per second, 150,000 miles per second, 180,000 miles per second, and then it crosses the line, 186,000 miles per second, the speed of light. At that exact instant, a shadow snaps into existence. It is as if a cloak has been thrown over the dying ember. The light that was trying to leave can no longer leave. The information that was trying to radiate is cut off. The event horizon is born. Inside that horizon, the core keeps shrinking. There is no force in the known universe that can stop it now. It shrinks to the size of a marble, a grain of sand, a microbe, an atom, and then it vanishes. It shrinks to a single mathematical point of infinite density. The Christian Singularity. Outside, everything is quiet. The supernova cloud drifts away. The explosion fades, and left behind, sitting in the center of the nebula, is the sphere of darkness. It is silent. It is calm. It shows no sign of the violence that created it. It is simply a scar on the vacuum. Think about the stillness of that aftermath. A few minutes ago, there was a giant raging star. Now, there is a geometrical quiet. The mass is still there. The gravity is still there. If there were planets orbiting that star, they might survive. They would continue to orbit the nothingness. Their sun has gone out, but its ghost is still holding them. This process, gravitational collapse, is happening all over the universe. Every time you look up at the night sky, there are thousands of these silent remnants hiding in the dark. They are the graveyards of the giants. But there is a beauty to it, because a black hole is not just a death, it is a transformation. It is matter changing state. It is the universe taking its messy, chaotic material and folding it into a perfect, permanent pocket. So, we have witnessed the birth. We have seen the floor give way. But now that the hole exists, what does it do to the space around it? How does it feel to be near it? Gravity usually feels like a gentle slope. But here, gravity becomes extreme. It stops being a hill and starts being a cliff. In the next chapter, we are going to explore the geometry of this extreme environment. We're going to find out what happens when you take the fabric of space-time and pull it tighter than a drum. Rest in the stability of our own sun. It will never do this. It will gently fade. We're safe from the crush. We saw the iron core collapse. We saw the floor of the universe give way, and we saw the birth of the shadow. Now, the violence is over. The supernova has faded. The gas has drifted away. We are left with the silence. We are drifting in the vacuum, looking at the result of that catastrophe. We are looking at a region of space where the rules of navigation have changed. Usually we think of space as a stage. It is flat. It is passive. It is the background where things happen. But here, near the black hole, space is not a background. It is an active, aggressive participant. Tonight, we are going to explore the geometry of the extreme. We're going to ask, what does it feel like when the fabric of reality is pulled tight? To understand this environment, we have to go back to our favourite analogy, the mattress. Imagine a soft, comfortable mattress. If you place a bowling ball in the centre, representing the sun, it creates a gentle dip. If you roll a marble past it, the marble curves slightly. This is the gravity we know. It is polite. It is manageable. But a black hole is not a bowling ball. A black hole is what happens when you take that bowling ball and crush it into the size of a pinhead, but keep the weight exactly the same. If you press a heavy pin into the mattress, it doesn't make a gentle dip. It creates a spike. It drags the fabric down into a deep, vertical throat. This is the shape of space in front of us. We're not looking at a hill. We're looking at a puncture wound in the cosmos. As we drift closer, let's say we move from 500,000 miles away to 100,000 miles away, we start to feel the texture of this space. And the first thing we notice is the tide. We usually think of tides as something that happens to the ocean. The moon pulls the water and we get high tide. But tide is just a word for a difference in gravity. The moon pulls the side of the earth facing it slightly harder than the side facing away. That difference stretches the earth. Here, the tide's not gentle, because the funnel is so steep, gravity gets stronger very fast as you get closer. Imagine you're floating feet first toward the black hole. Your feet are slightly closer to the hole than your head, maybe by only 6 feet. But in this extreme geometry, 6 feet matters. The gravity pulling on your feet is significantly stronger than the gravity pulling on your head. You feel a sensation of stretching. It feels as if invisible hands are gently pulling your feet down, while other hands are gently pulling your head up. You are being elongated. This is the beginning of what physicists call spaghettification, a funny word for a serious process. Right now, where we are, it feels like a nice stretch after a long nap. It is relaxing. But if we were to go much closer, that stretch would become stronger than your bones. It would unspool you into a long, thin stream of atoms. It is a reminder that we are entering a place where the human scale is irrelevant. The black hole does not care about biology. It only cares about geometry. And the geometry here demands that things become long and thin. But the stretching of space is only half the story. The more profound change is the stretching of time. We learned in our space-time series that gravity slows down time. The deeper you are in the well, the slower you age. On Earth, this effect is tiny. Your feet are 1/1000th of a nanosecond younger than your head. But here, the time dilation is palpable. The mud of space-time is thick. If you were to look back at the universe behind you, away from the hole, you would see something strange. You would see the stars changing. You would see them moving faster. You would see the galaxy rotating at a dizzying speed. Because your time is slowing down, the rest of the universe appears to speed up. You're slipping into a slow-motion bubble. A minute for you might be an hour for the outside world, then a day, then a year. You're effectively travelling into the future by simply hanging out near this heavy object. You're letting the river of time rush past you. If you stayed here for a while and then turned your ship around and went home, you would find that everyone you knew was gone. You would be a relic of the past stepping into their future. This is the seductive power of the black hole. It is a time machine. But it is a time machine that only goes forward, and it charges a heavy price for the ticket. Now, let's look at the light. We are getting closer. The black circle covers half the sky. We're entering a region called the photon sphere. This is one of the most magical places in the universe. Usually light travels in a straight line, but here the gravity is so strong that space is bent into a circle. At a specific distance from the hole, 1.5 times the radius of the event horizon, light can actually orbit the black hole. Think about what that means. If you were floating in the photon sphere and you shone a flashlight sideways, the beam of light would circle the black hole, come up behind you, and hit you in the back of the head. It means that if you looked straight ahead, you wouldn't just see the black hole. You would see the back of your own head. You would see the image of your ship hovering in front of you. You are standing in a hall of mirrors, but the mirrors are made of gravity. Light is trapped here, circling endlessly, waiting for a nudge to either fall in or fly away. It is a ring of suspended history. Ancient light, trapped from millions of years ago, might still be ghosting around this orbit. And there is another thing happening to the light. Look at the stars behind us again. They don't look white anymore. They look blue. Why? Because the light falling into the hole is gaining energy. It is falling down the slope, picking up speed, in energy terms, not velocity. It shifts toward the blue end of the spectrum. The universe above you looks brighter, harsher, and more energetic. But if you look down, if you toss a glow stick into the hole, the light from the glow stick has to climb out of the well to reach your eyes. It has to fight the gravity. It gets tired. It loses energy. It turns red, then deep red, then infrared. then silence. We call this gravitational redshift. It is the universe muting the volume of anything that gets too close to the edge. The whole is surrounded by a halo of fading whispers. So, here we are, suspended in the photon sphere, tides pulling at our feet, time slowing to a crawl, light circling our heads, the universe above speeding up, the universe below fading out. We're in the lobby of the abyss. The geometry here is extreme, but it is still technically outside. We could still fire our engines. It would take a lot of energy, but we could escape. We could break the orbit and climb back up the hill-to-the-flat safe space of the galaxy. But below us, just a few miles down, there is a line. It is not marked with a sign. It is not a solid wall. It looks exactly like the empty space we're in right now. But it is the most important boundary in physics. It is the edge of the waterfall. It is the place where the hill becomes a cliff. It is the event horizon. And once you cross it, geometry changes its job description. Space stops being a place you can move through, and time stops being a choice. In the next chapter, we're going to approach that line. We're going to ask the ultimate question. Why can't we get out? Is there a wall, or is it something much more subtle and much more terrifying? We're going to learn that the event horizon is not a prison wall. It is a broken bridge. But for now, hold your position here in the light. Watch the back of your own head float in the darkness. Marvel at the curve. In the last chapter, we drifted into the deep end of the universe. We parked our ship in the photon sphere, a place where the gravity is so strong that light itself is forced to orbit in circles. We saw the back of our own heads. We felt the tide pulling gently at our feet. We felt the strange sensation of time slowing down, while the universe above us seemed to speed up. But below us, there is a line. We are hovering just above it. From where we sit, it looks like the edge of a shadow. It is a perfect, sharp boundary between the distorted starlight and the absolute nothingness. Tonight, we're going to look at that line. We're going to study the most famous boundary in all of science, the event horizon. I want you to picture a waterfall. Imagine a wide, calm river flowing slowly toward a cliff. Far upstream, the water is lazy. You can swim against the current easily. As you get closer to the edge, the current picks up speed. It gets faster, stronger. If you are a strong swimmer, you can still fight it. You can stay in place. But eventually, the water reaches the lip of the cliff. At that exact point, the water is moving downward faster than any swimmer can swim upward. This is the perfect analogy for a black hole. Because according to Einstein, gravity is not just a force that pulls you. Gravity is space itself moving. Imagine that space, the vacuum, the fabric, the nothingness, is flowing into the black hole like water down a drain. Far away, the flow is slow, but as you get closer, the flow accelerates. Space is being sucked in. Now, remember the rule of the universe, the speed limit. Nothing can travel faster than light. Light is the fastest swimmer in the cosmos. It swims at 670 million miles per hour. So, let's look at the event horizon again. The horizon is not a solid surface. You cannot stand on it. You cannot knock on it. The horizon is simply the point in the river where the speed of the falling space equals the speed of light. If you are a photon of light and you're trying to escape, and you are exactly at the horizon, you're swimming upstream at 186,000 miles per second, but the space you are swimming in is falling downward at 186,000 miles per second. The result? You stay exactly where you are. You're running on a treadmill that is perfectly matched to your speed. You're frozen. You can never move forward to the outside world, and you can never move backward into the hole unless you give up. You're trapped on the edge of forever, but if you're just 1 inch inside that line, if you drift just a centimeter deeper, then the river of space is moving faster than light. Even if you're a beam of light, even if you are the fastest thing in existence, you will be dragged backward. The current is too strong. The waterfall has you. This is why the hole is black. It is not because the light is stuck. It is because the space containing the light is falling faster than the light can climb. The exit door is receding faster than you can run toward it. So, this boundary is defined by the struggle between the speed of light and the flow of space. We call this radius the Schwarzschild radius, named after Karl Schwarzschild, a German physicist who calculated it in 1915. He found this beautiful, perfect solution while he was serving in the trenches of World War I. Amidst the noise and chaos of war, he found the formula for the ultimate silence. He realized that any object can become a black hole if you crush it small enough. If you crush the sun down to 3 kilometers wide, the escape velocity becomes the speed of light. The horizon appears. If you crush the Earth to the size of a peanut, the horizon appears. If you crush a human being to the size of an atom, a tiny microscopic horizon appears. The horizon is just the no trespassing sign that appears when mass gets too dense. But tonight, I want you to reframe how you feel about this line. Usually we think of it as a prison wall, the point of no return. It sounds ominous, it sounds like a trap, but I want you to think of it as a one-way membrane. Think of a window that is perfectly transparent from the outside, but perfectly opaque from the inside. Information can flow in. We can throw rocks, light, radio waves, and love letters into the hole. The hole accepts them all, but nothing can flow out. This protects us. Inside the hole, the laws of physics are breaking down. Causality is twisting. Time is turning into space. It is a region of chaos and paradox. The event horizon is the quarantine wall. It wraps up that chaos and hides it from the rest of the universe. It prevents the madness inside from infecting the logic outside. It is a cosmic shield. And what does it look like? As we hover here, looking down at it, it is the blackest thing you can imagine. A piece of black paper reflects a little bit of light. Vantablack paint reflects a tiny bit of light. But the event horizon reflects absolutely nothing. Zero. It is a hole in the visual field. Because it has no surface features, it is incredibly smooth. It is a perfect sphere. There are no mountains to cast shadows, no valleys to catch light. It is the simplest geometric shape in nature. It is pure mathematical darkness, and because it is so smooth, it creates a strange optical illusion. If you were to fly around it, it would look flat, like a black disk painted on the sky. Only the bending of the stars around it reveals its spherical nature. But here is the strangest thought of all. If you were to cross this line, you wouldn't know it. Imagine the waterfall again. If you're in a boat and you drift over the edge of a really, really tall waterfall and you close your eyes, do you feel the moment you cross the edge? No, you just feel the fall. The water around you is falling with you. Everything is calm in your immediate vicinity. The event horizon is not a wall of fire. It is not a barrier. It is just empty space. If we turned off our engines and let our ship drift across the line, nothing dramatic would happen right here. The alarm bells wouldn't ring, the The ship wouldn't shake, we would just be drifting. But if we tried to turn around, if we tried to fire our engines to go back, that is when we would realize the truth. We would find that back is no longer a direction. This is hard to visualize, so let me try to paint it for you. In the normal world, you can move in 3 directions: up, down, left, right, forward, backward, and you move in one direction through time, future. You have no choice about time, you must go to the future, but you have total freedom in space. You can go to the kitchen and you can come back. Inside the event horizon, the geometry flips. Space becomes like time, and time becomes like space. The radial direction, the direction toward the center of the whole, becomes your future, and the direction out, away from the whole, becomes your past. Think about that. Can you turn your ship around and fly into the past? No, it is impossible. Yesterday is gone. Inside a black hole, the outside world is yesterday. You can see it, maybe, but you can never, ever go there again. It is not a matter of having a strong enough engine. It is a matter of logic. You cannot fly to a place that exists in your past. So, falling toward the center becomes as inevitable as next Tuesday. You don't have to push. You don't have to steer. Time itself drags you down. This is why escape is impossible. Not because the gravity is pulling you, but because the geometry has removed out from the list of possible futures. There is no road that leads away. All roads, every single possible path, leads in. This is a heavy thought. It makes the event horizon feel like the ultimate end, the final chapter of any story that crosses it. But looking at it from the outside, from where we are safe, it is just a quiet sphere. It is a vault. The universe deposits its secrets there, and the horizon keeps them safe. So, as you lie in bed, think of the horizon not as a monster's mouth, but as the limit of our knowledge. It is the edge of the map. Here there be dragons. We humans are obsessed with knowing everything. We want to see everything. But the event horizon tells us, no. It tells us, some things are not for you. Some things belong to the silence. There is a peace in accepting that. There is a peace in knowing that there are mysteries that will never be solved. The black hole is the universe keeping a secret, but there is a difference between crossing the line and watching someone else cross the line. Time plays a trick on us here. If we stay on the ship and we drop a probe into the hole, we will never see it cross the horizon. We will see it stop. We will see it freeze. We will see it hang there on the edge of the darkness forever. Why? Why does the universe refuse to show us the moment of crossing? In the next chapter, we're going to look at the illusion of the frozen star. We're going to explore why, from our perspective, nothing ever truly falls into a black hole. History piles up at the door, like snow against a window. It is a trick of the light, and it is the subject of Chapter 6. But for now, float here in the photon sphere, safe, above the waterfall, watching the silent black river flow down into the dark. We hovered just above the edge. We looked down at the event horizon, the invisible line where the river of space flows faster than light. We learned that it is a one-way membrane, a door that locks from the inside. But tonight, we're going to perform a magic trick. We're going to split reality in two. We're going to see that what happens near a black hole depends entirely on where you're standing. I want you to imagine two people. Let's call them Alice and Bob. Physics loves Alice and Bob. They're astronauts on a mission to the black hole. Alice is the brave one. She's going to fly a small probe down toward the event horizon. Bob is the cautious one. He's going to stay on the main ship, parked safely far away in the flat, quiet space. This chapter is the story of what Bob sees. It is the story of the as-frozen star. Bob sits in the captain's chair. He has a powerful telescope trained on Alice's probe. Alice's probe has a bright blue beacon on the back, flashing once every second. Tick, tick, tick. She waves goodbye and starts her descent. At first, everything looks normal. Alice falls toward the black circle. She picks up speed. Gravity is pulling her in. Her beacon flashes steadily. Tick, tick, tick. But as she gets closer to the event horizon, Bob notices something strange. The flashes start to slow down. Tick, tick, tick. Bob checks his own watch. His watch is ticking normally, but Alice's time is dragging. She is entering the deep gravity well. She is wading into the thick mud of curved space-time. To Bob, her movements become sluggish. He sees her wave her hand, and it is a slow, languid motion, like she is moving through molasses. Tick, tick, tick. Now she is very close to the edge. The light from her beacon is also changing. It has to climb out of the deep gravitational valley to reach Bob's telescope. As it climbs, it loses energy. It gets tired. The bright blue light shifts to green, then yellow, then orange, then deep, dim red. We call this gravitational redshift. Alice is fading. She's becoming a ghost. And then she reaches the horizon. Bob leans forward. He expects to see her disappear. He expects her to pop out of existence as she crosses the line. But she doesn't. As Alice hits the event horizon, time dilation becomes infinite. From Bob's perspective, her time stops. Bob sees Alice freeze. She hangs there, suspended exactly on the edge of the darkness. Her image is motionless. The last photon of light she emitted before crossing takes an infinite amount of time to climb out to Bob, so Bob never sees her cross. He waits for a minute. She is still there. He waits for a year. She is still there. He waits for 1,000,000 years. She is still there. Fainter, redder, ghostlier, but there. This is the great illusion of the black hole. To the outside universe, nothing ever truly falls in. The black hole is coated in a layer of frozen history. Every rock, every gas cloud, every spaceship that has ever fallen toward it is plastered onto the horizon like a sticker on a suitcase. All of them frozen in the last moment before their doom. This is why, for a long time, Russian physicists didn't call them black holes. They called them frozen stars, because that is what they look like from the outside, objects where time has congealed into ice. But this is only Bob's reality. What about Alice? We have to remember the central rule of relativity. There is no single now. Bob has his now, Alice has her now, and near a black hole, those two nows are ripped apart completely. Let's switch cameras. Let's jump into the probe with Alice. Alice is falling. She looks at her own watch. Tick, tick, tick. It is ticking perfectly normally. She doesn't feel slow. She feels fine. She looks back at Bob. What does she see? If Bob sees Alice slowing down, Alice must see Bob speeding up. She's looking out from the slow time well into the fast time universe. She sees Bob moving like a hummingbird. She sees the main ship orbiting frantically. She sees the stars in the sky whirling overhead. She's watching the future of the universe play out in fast forward. Millions of years might pass outside in the few minutes she falls, and then She approaches the horizon. She braces herself for impact. She expects a wall, a barrier, a sign that says the end. But she sees nothing. She crosses the line without a bump. The event horizon is just empty space to her. Her watch keeps ticking. Her heart keeps beating. She is alive. She is thinking. But she has done something impossible. She has left the observable universe. She has crossed a boundary that creates a permanent disconnection from Bob. Bob sees her frozen forever on the edge. But Alice is already gone. She's plummeting toward the center. This creates a paradox. How can she be in two places at once? How can she be stuck on the horizon for Bob and falling toward the center for Alice? This is the black hole information paradox. It is a deep argument in physics. Does the information about Alice stay on the surface, or does it go inside? Leonard Susskind and Stephen Hawking fought a famous war over this question. The answer seems to be a concept called complementarity. It suggests that both stories are true. From the outside, she never enters. From the inside, she definitely enters. Nature somehow maintains two contradictory realities at the same time, protected by the fact that the two Alices can never talk to each other again. But let's go back to Bob. Let's go back to the safety of the ship. Bob is staring at the frozen image of Alice. Does he see her forever? Practically speaking, no. Remember the redshift. As Alice freezes, her light gets dimmer and dimmer. The time between photons gets longer and longer. Eventually, the last visible photon arrives. Then, the last infrared photon. Then, the last radio wave. And then, silence. She fades to black. She doesn't disappear spatially. She disappears visually. She becomes a part of the silence. This teaches us something profound about the universe. It teaches us that observation is not reality. Just because Bob sees her stop doesn't mean she stopped. Just because we can't see the inside doesn't mean it doesn't exist. The universe has secrets. It has pockets of reality that are completely cut off from our timeline. Alice is having an experience right now that Bob can never know. She's exploring a new region of space-time, a region where the rules of geometry have flipped. So, as an outside observer, a black hole is a tomb. It is a static, unchanging sphere of darkness. It is a place where things go to stop. But we know better. We know that the stillness is a lie. We know that just past that frozen image, there is a waterfall, there is motion, there is a desperate, one-way rush toward destiny. And tonight, we're going to be brave. We're not going to stay with Bob. Bob is safe, but Bob is bored. We're going to follow Alice. We're going to do the one thing you are never supposed to do. We're going to cross the line. We're going to find out what happens when you step off the edge of the known map. We're going to find out what Tuesday looks like when it becomes a place you can fall into. So, say goodbye to the starlight. Say goodbye to the universe you know. The familiar constellations are about to be warped beyond recognition. Take a deep breath. The plunge begins in the next chapter. In the last chapter, we watched a tragedy from a distance. We stood on the deck of the main ship with Bob safely far away. We watched Alice's probe fall toward the darkness. We saw her light turn red. We saw her movement slow down. And finally, we saw her freeze. To the outside world, she became a permanent fixture of the sky, a frozen star stuck forever on the edge of the abyss. But tonight, we're going to leave Bob behind. We're going to abandon the safety of the outside universe. We're going to buckle ourselves into the seat next to Alice. We're going to do the thing that physics says is impossible to report on. We're going to cross the line. I want you to take a deep breath. Feel the calmness of the cabin. The air is still. The hum of the engine is steady. You're falling at nearly the speed of light. But because you are in free fall, you feel perfectly weightless. You are floating in your chair, suspended in the quiet dark. Ahead of you is the event horizon. From the outside, it looked like a sharp black edge against the stars. But now that we are here, right on top of it, it looks different. It fills your entire forward view. It is an ocean of blackness, a void so total that your eyes strain to find any detail. But there is no detail. It is simply the absence of light. You check your distance gauge. 10 miles to the horizon. 5 miles. 1 mile. You brace yourself. You instinctively expect a crash. You expect a barrier, a wall of fire, a jolt of electricity, something to mark the boundary between the known and the unknown. And then the counter hits 0. What happens? Nothing. Absolutely nothing happens. There is no bump. There is no flash. There is no sound. The ship doesn't shake. The alarms don't ring. Your heart keeps beating at the same rhythm. Your watch keeps ticking. Tick, tick, tick. You look around the cabin. The coffee cup is still floating. The lights are still on. You look at your hands. They look exactly the same. This is the most surprising secret of the black hole, the no drama principle. According to Einstein's equivalence principle, space is space. The vacuum inside the black hole is made of the exact same stuff as the vacuum outside. It has no signposts, it has no borders. If you had your eyes closed, you wouldn't even know you had crossed it. You've just slipped past the most dangerous line in the universe. And it felt like walking through an open door in a dark room. But while the local experience is calm, the global reality has changed forever. You are now in a new world, a world with different rules. Let's look out the back window. Let's look at the universe we just left. Behind you, the sky has changed. The entire universe, the billions of galaxies, the stars, the nebula, the ship where Bob is waiting, has been compressed. Because of the extreme bending of light, the outside world now looks like a bright circular window behind you, porthole of starlight, and the darkness is everywhere else. It has wrapped around you. It feels intimate. It feels like the universe has shrunk down to the size of your ship. Now, let's try to do something. Let's try to stop. You realize you've crossed the line. You decide you want to go back. You grab the controls. You fire the main thrusters. You point the ship directly away from the center, directly toward that bright porthole of stars. You push the throttle to maximum. You expend enough energy to move a planet. What happens? In normal space, firing your engines pushes you forward. You gain distance. But here, something terrifying happens. You fire the engines, and you still fall backward. Actually, it is worse than that. By firing the engines, by adding energy to your system, you actually make your fall faster. You hit the center sooner than if you had just relaxed. Why? Why have the controls stopped working? This brings us to the profound shift in geometry. This is the moment where space-time flips. I want you to imagine a timeline. In your normal life, time is a direction you must travel. You're traveling from Monday to Tuesday. Can you turn around and go back to Monday? No. The geometry of the universe forbids it. The arrow of time pushes you relentlessly forward. But space? Space is optional. You can go left, right, up, down. You have freedom in space. Inside the event horizon, the variables switch roles. The radial direction, the distance to the center, becomes time. And the time coordinate becomes space. This is hard to wrap your mind around, so feel it instead. Think about the center of the black hole, the singularity. Outside, the singularity was a place. It was a location in the center of the sphere, but inside, the singularity is not a place, it is a time. It is an event in your future. It is next Tuesday. Asking, where is the singularity, is now the wrong question. The right question is, when is the singularity? And just as you cannot stop next Tuesday from arriving, you cannot stop the singularity from arriving. It is in front of you. It is behind you. It is to your left. It is to your right. No matter which way you turn your ship, you are turning toward the future. And the future is the singularity. This explains why you cannot escape. You cannot leave the black hole for the exact same reason you cannot travel to the year 1990. The outside is no longer a place. The outside is the past. And you cannot travel to the past. It is a trap made of logic. This realization usually brings panic, but I want you to feel the peace of it. There is a strange comfort in the inevitable. The struggle is over. There are no more choices to make. There is no more navigation to do. The current has you. You are flowing down the river of space at twice the speed of light, 3 times the speed of light. The waterfall is rushing you toward the end of time. So, what do? You turn off the engines. You sit back in the chair. You watch the bright circle of the universe behind you. It is a beautiful window. You can see the history of the galaxy playing out, because time is moving differently here. You're watching the external world age rapidly. Stars are being born and dying in the blink of an eye. Civilizations are rising and falling in that circle of light. You're a time traveler at the end of the world, but notice something else. You're still alive. The tidal forces, the spaghettification we talked about earlier, depend heavily on the size of the hole. If this were a small black hole, you would be dead by now, stretched into atoms. But let's assume we've chosen a supermassive black hole, a gentle giant, like the one in the movie Interstellar, or the one in the center of our galaxy. For these giants, the tidal forces at the horizon are weak. Your feet are only being pulled slightly harder than your head. It feels like a gentle stretch, a yoga pose. You have hours, maybe days, before the geometry becomes sharp enough to hurt you. You have time to think. You have time to wonder. What is happening to the light that fell in with you? You're not alone in here. Billions of years of starlight have fallen into this hole before you. Where is it? If you look to the side, do you see the other travelers? Do you see the ghosts of planets that were swallowed eons ago? In a way, yes. The light from those objects is trapped in here too. It is falling alongside you. It is trying to escape, moving outward at the speed of light, but falling inward at twice the speed of light. It is drifting backward with you. You're surrounded by a cloud of lost history, images of ancient stars, beams of light from dead civilizations, all of it preserved in the amber of the interior, but because everything is falling inward, the light from things below you can never reach you. You can never see what is ahead of you. You can only see what is behind you. You're falling blind into the future. The darkness ahead is absolute. It is not just dark. It is the absence of any possible signal. The future is a secret. So, here we are, inside the vault. We have done the impossible. We have survived the crossing. We are now residents of a new universe, a universe that shrinks every second. The walls are closing in, not physical walls, but the geometry itself. The space available to you is getting smaller. The paths are narrowing. All roads are converging. In the next chapter, we're going to explore this shrinking room. We're going to ask, what happens to light inside? If I shine a flashlight, does the beam fall to the floor? Does it spiral? Does it circle? And we're going to look at the direction of time itself. Is it possible that inside here, space and time are so broken that we could loop back? Could we find a wormhole? Or is the road to the centre truly a one-way street? The journey's not over yet. We still have a few hours of now left before the end. Let's use them to look around. The river is fast, but the ride is smooth. In the last chapter, we took the ultimate step. We left the universe of Bob, the Earth, and the stars behind. We drifted across the silent, invisible boundary of the event horizon, and we found ourselves in a new world. We are now falling, but remember, falling here feels like floating. You're sitting in your chair. The cabin is quiet. The lights are soft. If you didn't look out the window, you might think you were simply drifting in deep space, midway between the Earth and Mars. But you're not in deep space. You are in deep space-time. Tonight, we're going to explore the rules of this new house. We're going to play with a flashlight. We're going to look at the geometry of light beams. And we're going to understand why direction itself has lost its meaning. I want you to imagine you are holding a high-powered flashlight. You are sitting in the pilot's seat, facing away from the center of the black hole. You are facing back toward the way you came, back toward the event horizon. Through the rear window, you can see the distorted circle of starlight, the porthole to the universe you left behind. You decide to send a signal to Bob. You want to tell him, I made it. I am safe. It is quiet here. You aim the flashlight at the window. You turn it on. Click. A beam of pure white light shoots out of the lens. Inside the cabin, everything looks normal. The beam travels away from you at the speed of light, 670 million miles per hour. It hits the back window. It goes through the glass. It enters the vacuum outside. In your mind, you imagine that beam of light climbing back up the slope. You imagine it flying out of the hole, crossing the horizon, and travelling back to the main ship. But that is not what happens. Let's switch to the river view of space. Remember, inside the horizon, space is flowing inward like a waterfall, and right now, that waterfall is moving faster than light. Let's say the space around your ship is flowing downward at twice the speed of light. You fire the beam upward at 1 times the speed of light. It is a simple subtraction problem. 2 plus 1 equals to 1. The beam of light is moving away from you, but it is still moving toward the center of the hole at the speed of light. It is flying backward. Think about the tragedy of that beam. It is trying so hard. It is running at maximum velocity toward the exit, but the ground beneath it is rushing away too fast. The beam will never reach the horizon. It will never reach Bob. It will eventually turn around and crash into the singularity just like you. This means you are cut off. The definition of event horizon is not just about matter, it is about causality. It means that no event that happens in here can ever be the cause of an event out there. Your history has forked. You are now in a private timeline, a timeline that can receive messages but never send them. Now, let's try another experiment. Let's try to look sideways. Turn your ship so you're facing east. if east existed here. You fire the flashlight sideways. Usually light travels in a straight line, but here the gravity is so intense that space is twisted into a spiral. The beam of light leaves your ship, and it immediately bends downward. It arcs toward the center. There are no straight lines here. Every path curves down. If you tried to shine a laser grid to map the room, the grid would warp. It would look like a melting painting. The geometry of Euclid, the geometry of flat triangles and parallel lines, is gone. We are in the geometry of Riemann, the geometry of the curve. This brings us to the concept of light cones. In an earlier chapter, we talked about the light cone as the bubble of influence around you. Usually your future light cone points up toward tomorrow, and your past light cone points down toward yesterday. But inside a black hole, the gravity is so strong that it has tipped the cones over. Imagine a traffic cone sitting on the road. Now, knock it over on its side. Now, point the open end toward the drain. That is your reality, your entire future. Every single possible path your life can take is contained inside that tipped over cone, and the cone is pointing directly at the singularity. This is why we say space becomes time. Outside, you have 360 degrees of freedom in space. Inside, all those degrees of freedom point to one place. The center is no longer a location in the room. The center is an event in your future. It is inevitable. Trying to avoid the singularity is like trying to avoid next Tuesday. You can wiggle, you can dance, you can fire your engines left or right. But every second that ticks by brings you closer to Tuesday, and every meter you fall brings you closer to the center. But let's look at what we can see. We said earlier that we can't send messages out, but we can still receive them. Look out the back window again. That porthole of starlight is getting smaller. As you fall deeper, the darkness wraps around you tighter. The view of the outside universe shrinks into a bright, concentrated disk of light behind you. But look at the color of that light. It is beautiful. It is shifting. Because you are falling away from the light, you might think it would look red, redshift. But there is a competing effect. The light falling in after you is gaining energy from the fall. It is falling down the gravity well, picking up speed, energy. This creates a blue shift. The light from the universe behind you is becoming harsh and bright. It shifts from yellow to blue to ultraviolet. If you looked at it with special instruments, you would see X-rays. You're being showered by the history of the galaxy. Light that left stars millions of years ago is pouring into the hole and catching up to you. You're watching a movie of the universe on fast forward. It is a condensed high-energy download of the cosmos. And what about the view forward? What do you see when you look toward the destination? You turn your chair around. You face the darkness. You expect to see something. The monster, the core, the hard surface of the dead star. But you see nothing. Absolute black. Why? Because for you to see something, light has to bounce off it and come to your eyes. But nothing can bounce off the singularity and come back to you. That would require the light to move outward. And we just learned that outward movement is impossible. The river flows down. Nothing swims up. So, the singularity is cloaked in silence. You will never see it coming. You will simply fall through the dark until you arrive. This sounds terrifying. But in the quiet of this room, try to feel the peace of it. There is a strange serenity in a one-way universe. Navigation is no longer your problem. You don't have to steer. You don't have to decide where to go. The universe has taken the wheel. You are simply a passenger on the final ride. And time, what is time doing to you? We talked about time slowing down for Bob, the outside observer, but for you, your watch is ticking, tick, tick, tick. Your heart is beating, thump, 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 but the space around you is shrinking. This is the feeling I want you to focus on as we drift deeper, the sensation of focus. Imagine you're in a large room. Slowly, the walls start to move in, not to crush you, but to focus you. The universe is removing the distractions. It is taking away the left and the right. It is taking away the up and the down. It is leaving you with only one dimension, the dimension of towards. You're being distilled. The black hole is refining you. It is stripping away the complexity of your trajectory and turning you into a straight line. And despite the violent reputation of black holes, this part of the journey is smooth. If the hole is large enough, the tidal forces are still gentle. You're not being stretched yet. You're just falling. Falling through a region of space that has been cut off from the rest of reality since the beginning of time. You're the first explorer to see this dark room. You're seeing secrets that no telescope on Earth will ever see. You are privy to the hidden architecture of God, and as you fall, you might wonder, is there a bottom? Is the singularity a hard floor, like a planet? Or is it a hole in the floor? Is it a gateway? Science fiction loves to imagine that black holes are wormholes, that if you survive the fall, you might pop out in another universe, or in another time. A white hole somewhere else in the cosmos spewing you back out. Physics tells us this is probably not true. The math suggests the singularity is an end, not a door. But we don't know for sure, because at the very centre, the math breaks. The smooth curve of relativity crashes into the jittery chaos of quantum mechanics. Nobody knows what happens at the centre. Maybe it is a door. Maybe it is a library of all the lost information. Maybe it is a reboot button. We're not there yet. We still have some time. We're falling through the quiet middle ground, the region between the horizon and the end. So, lean back. Watch the blue light of the universe behind you. Feel the darkness ahead of you. You are suspended between the past and the future in a way that no human has ever been. You're riding the arrow of time directly into the heart of the mystery. In the next chapter, we're going to talk about the geometry of the room itself. We're going to visualize the shape of space-time when it is twisted into a funnel. And we're going to prepare ourselves for the final approach. But for now, float. You're safe in the capsule of the present moment. The future will arrive when it arrives. In the last chapter, we did something that human beings have dreamed of doing for 100 years. We crossed the threshold. We drifted past the event horizon and entered the interior of a black hole. We found that it wasn't a violent crash. It wasn't a wall of fire. It was a quiet slip into a new kind of reality. We're now falling through the dark. We're moving toward the center. But tonight, we need to look at the walls of this room. We need to understand the architecture of the space we are inhabiting. Usually when we think of geometry, we think of something static. We think of the corners of a room, the parallel lines of a highway, the grid of a city. These things stay still. You move through them. The room doesn't change shape just because you walked across it. But here, in the deep interior, geometry is not static. It is dynamic, it is alive, and it is aggressive. Tonight, we are going to explore the geometry of the collapse. We are going to visualize what happens when space-time itself is being strangled. I want you to imagine you're in a long, dark tunnel. You're floating down the center of this tunnel. Far ahead of you, you can see a tiny point, the destination. Far behind you, you can see the light of the entrance fading away. Now, imagine the tunnel is not made of concrete. It is made of directions. Up, down, left, right. In normal space, these directions are infinite. You can go left forever. You can go up forever. But inside the black hole, the tunnel is shrinking. This is the first feature of our new geometry. Convergence. Imagine you're driving on a massive highway with 1,000 lanes, but slowly, the lanes start to merge. The painted lines on the road get closer together. The cars are forced to pack in tighter. Eventually, all 1,000 lanes merge into a single lane. This is what is happening to the left and right directions inside the hole, because everything is falling toward a single point, the singularity. All the paths are being squeezed together. This creates a physical sensation. We talked earlier about the tide, the feeling of being stretched head to toe. That happens because your feet are closer to the center than your head. The gravity pulls them harder. That is the vertical stretch. But there is a second force, the horizontal squeeze. Think about the merging traffic. As the lanes merge, the cars get pushed in from the sides. If you were made of soft clay, and you were travelling down this converging highway, you would be squished sideways. Your shoulders would be pushed in. Your waist would be compressed. So, the geometry of the black hole is acting like a rolling pin. It is pulling you long, head to toe, and it is squeezing you thin, side to side. This is why physicists call it spaghettification. It turns you into a noodle. It is the universe trying to force a 3D object to fit into a 1D point. But remember, we are in a supermassive black hole. The tunnel here is very, very wide. The squeeze is happening, but it is happening slowly. Right now you don't feel pain. You just feel a gentle pressure, a feeling of being held, a feeling of being contained. The universe is wrapping you up. It is removing your width. It is removing your bulk. It is streamlining you for the final journey. Now, let's add another layer to this geometry. So far we have imagined the fall as a straight line down a funnel, but in nature, nothing is perfectly straight. Most stars spin. The Earth spins. The Sun spins. The galaxy spins. So, when a star collapses to form a black hole, it keeps that spin, and because it gets smaller, it spins faster. A real black hole is a tornado. So, the tunnel we are falling through is not just shrinking, it is twisting. This is a phenomenon called frame dragging. It is one of the wildest predictions of Einstein's theory. It says that a spinning object doesn't just spin in space, it grabs the space around it and drags it along. Imagine a spoon spinning in a cup of thick honey. The honey near the spoon starts to spin too. If you put a peppercorn in the honey, it will spiral. Even if the peppercorn tries to stay still, the honey carries it around. You are the peppercorn, the black hole is the spoon, and space-time is the honey. So, as you fall, you're not falling in a straight line. You're spiraling. You're caught in a great dark whirlpool. The entire geometry of the room is rotating around you. If you looked at the porthole of starlight behind you, you wouldn't just see it receding, you would see it spinning. The universe outside would look like it was revolving around you at a dizzying speed. But you feel still, because you are moving with the space. It is a smooth, silent spiral into the deep. This twisting geometry creates a strange shape at the center. If the black hole is spinning, the singularity is not a point, it is a ring. The centrifugal force of the spin stretches the center into a thin, razor-sharp circle of infinite density, a ring singularity, and this opens up a bizarre possibility in the math. If you fall toward a point, you hit it. Splat. End of story. But if you fall toward a ring, and if you are precise enough, you could theoretically fall through the middle of the ring, like a diver jumping through a hoop. What happens if you go through the ring? The equations of general relativity, when pushed to their breaking point, suggest that the center of the ring might be a gateway to a negative space, or a white hole in another universe, or a different time. It is called the Kerr solution. It suggests that the interior of a spinning black hole is not a dead end, but a bridge, a wormhole. Now, we have to be careful here. This is where the math gets dreamy. Most physicists believe that this bridge is unstable. They believe that as soon as you try to cross it, the energy of your own ship would collapse the tunnel. The bridge would snap shut the moment you touched it. But we are here for a sleep story. We are here to dream. So, hold on to that possibility. The geometry ahead of you is not necessarily a wall. It might be a passage. But let's come back to the now. Let's come back to the feeling of the fall. We are deep inside. The horizontal squeeze is getting stronger. The vertical stretch is getting stronger. The twist is getting faster. The room is actively changing shape around us. It is like being inside a kaleidoscope that is slowly turning. The directions are rearranging themselves. And there is one final geometric trick that the black hole plays on us. It swaps the roles of space and time. We talked about this briefly in the last chapter, but let's visualize it. Think of a chessboard. On a normal chessboard, you can move your pawn forward, backward, left, or right. But time pushes the game forward turn by turn. Inside the black hole, the board tilts. It tilts so steeply that forward becomes down, and down becomes tomorrow. The distance to the singularity is no longer measured in miles. It is measured in seconds. You're not 100 miles from the center. You're 0.05 seconds from the center. This is why the geometry feels so claustrophobic. It is not just that the walls are closing in. It is that time itself is running out of room. You're falling toward the end of time, not the end of the universe's time, the end of your time. This singularity is the moment where your clock stops ticking, but, looking around the cabin, it is still peaceful. The coffee is still warm. The lights are still soft. The laws of physics are holding you together for just a little longer. You're experiencing a region of the universe that is private. No one outside can see you. No one can hear you. You are hugged by the event horizon. You are cradled in the twist. It is the ultimate solitude, a place where the universe is curled up into a ball to protect a secret. So, do not fight the squeeze. Do not fight the spiral. Lean into the curve. You're a geometric shape sliding through a geometric machine. You fit perfectly. The tunnel was made for this. We are nearing the end of the journey. Ahead of us lies the singularity, the monster at the end of the book, the point of infinite density, the place where the math breaks. What will happen when we hit it? Will we be crushed? Will we pass through? Or will we simply stop? In the next chapter, we are going to confront the core. We are going to ask what lies at the bottom of the well. And we're going to realize that even there, even at the point of destruction, there is a strange kind of peace. But for now, Spiral down. Let the frame dragging carry you. You are dancing with the shadow. We were spiraling down the throat of the black hole, carried by the rotating geometry of space-time. We felt the walls closing in. We felt the squeeze of the converging paths. We learned that inside this place, forward is no longer a direction in space, but a direction in time, and all roads lead to the same destination. Tonight, we arrive. We're going to confront the thing that lives at the bottom of the well. We're going to look at the best singularity. I want you to take a moment to appreciate where we are. We have passed the event horizon, the point of no return. We have passed the photon sphere, the ring of trapped light. We have survived the spaghettification, the tidal stretching. We are now floating in the deepest, darkest, most secret room in reality. Ahead of us, in the center of the spiral, is the core. But what is it? If you ask Isaac Newton, he would say it is a heavy ball. If you ask Albert Einstein, he would say it is a point where the math explodes. If you ask a quantum physicist, he might say it is a ball of fuzz. Tonight, we're going to look at all three possibilities, because the truth is, nobody knows. This is the edge of human knowledge. This is the here be dragons of physics. Let's start with the classical view, the view of general relativity. This is the theory that guided us here. It has been perfect so far. It predicted the horizon. It predicted the time dilation, so we should trust it, right? According to general relativity, the singularity is a schema. Point of infinite density. I want you to try to visualize infinity. It is impossible. Our brains are built for finite things. We can imagine a heavy rock. We can imagine a mountain. We can imagine a star. But imagine taking a star, a ball of fire 1,000,000 miles wide, and crushing it. Smaller than a planet. Smaller than a house, smaller than a marble, smaller than an atom, smaller than a proton. Keep going, crush it until it has zero size. It takes up no space at all. It has no width, no height, no depth, but it still has the mass of a star. If you divide a huge number, mass, by zero, volume, you get infinity, infinite density, infinite gravity, infinite curvature. The rubber sheet of the space-time doesn't just dip. It doesn't just stretch. It rips. It plunges down into a bottomless depth. If this theory is true, then the thing ahead of us is not an object. It is a glitch. It is a place where the laws of physics have divided by zero and crashed the computer. It is the end of space-time itself. If you were to hit it, you wouldn't just be crushed. You would cease to exist as an entity in the universe. Your world line, the thread of your life, would simply stop. It is a terrifying thought, a hard stop to reality. But nature rarely deals in infinities. Usually when a theory predicts infinity, it means the theory is wrong. It means we are missing a piece of the puzzle. And we know we are missing a piece, because general relativity is not the only ruler of the universe. There is another king. Quantum mechanics. Quantum mechanics rules the world of the tiny. Atoms, electrons, quarks. And right now, the singularity is tiny. So quantum mechanics should be in charge. And quantum mechanics hates the idea of a point. It says that you can never pin a particle down to a specific location. The uncertainty principle. Everything is fuzzy. Everything is a wave. Everything is a cloud of probability. You cannot crush a star to zero. The universe won't let you. At some point, the pixels of reality get too big to hide the details. So, what happens when these two theories crash into each other? What happens when the unstoppable force, gravity, meets the immovable object quantum uncertainty. We don't know. We haven't found the theory of everything that unites them. But we have some guesses, and they are beautiful guesses. One guess is loop quantum gravity. This theory suggests that space-time is not a smooth sheet, it is a mesh. A chainmail armor made of tiny, tiny loops. You can't crush the loops to zero. There is a minimum size. So, when the star collapses, it doesn't go to infinity. It crunches down to the smallest possible nugget of space, called a Planck star, and then it bounces. Imagine a ball falling in slow motion. It hits the floor, it compresses, and then it springs back. Some physicists believe that inside every black hole, there is a slow motion bounce happening, but because of the extreme time dilation, the bounce takes billions of years to happen from the outside. To us, it looks like a hole, but from the inside, it might be a Big Bang. The matter is expanding outward into a new space, a new universe. The black hole is not a tomb, it is an egg, and we, falling into it, are the seeds of a new galaxy. This is a lovely thought. It means the singularity is not an end. It is a bridge to a white hole somewhere else. There's another guess. String theory. String theory says that the singularity is a set fuzzball. It suggests that when the matter gets crushed, it turns into a giant tangled ball of vibrating strings, like a yarn ball the size of a city. If you fell into it, you wouldn't be destroyed, you would be assimilated. Your atoms would turn into strings, you would vibrate, you would become part of the music of the whole, and there is a darker guess. The firewall. Some physicists argue that you never even make it to the center. They argue that the quantum energy at the event horizon creates a wall of pure fire. You burn up the moment you enter. The interior is a lie. There is no inside. Space ends at the door. But let's go back to the experience. Let's forget the theories and feel the moment. We are falling. The squeeze of the tidal forces is now extreme. If we were biological beings, we would be gone. But remember, in this story, we are consciousness. We are pure observers. We can survive the squeeze. We approach the center. The darkness is absolute. But there is a sense of presence. You are approaching the mass of 1,000,000 suns huddled together in the dark. Think about the intimacy of this. Every atom that ever fell in here is waiting for you. The gas from ancient nebulas, the light from dead stars, the dust of lost planets. It is all here, compressed, unified. In the outside world, things are separate. You are here. The chair is there. The sun is far away. Separation is the defining feature of our lives. Space keeps us apart. But here, space has failed. Here, separation is impossible. Everything is occupying the same location. Everything is touching. The singularity is the ultimate state of oneness. It is the place where the universe forgets that it has parts and remembers that it is a whole. If you hit the singularity, you are not destroyed. You are integrated. Your mass becomes the black hole's mass. Your energy becomes the black hole's energy. Your spin adds to the black hole's spin. You lose your name, you lose your shape, you lose your history, but you gain unity. You become the heavy anchor that holds the galaxy together. So, as we hover here, nanoseconds away from impact, do not feel fear. Fear comes from the ego. Fear comes from the desire to be separate. Here, the geometry demands surrender. And if the rotating ring theory is true, if the center is a gateway, then you are about to thread the needle. You're about to pass through the eye of the storm. Imagine flying through the ring. The tidal forces are pulling you apart, but the centrifugal force is pushing you out. There is a calm channel in the middle, a hurricane eye. You slip through, and suddenly the darkness breaks. The crushing gravity reverses. You are spewed out. Light explodes around you. White light, new light, a new sky, a new time. Or perhaps you just wake up. Because the singularity is also a metaphor for the unknowable. It is the limit of the mind. We cannot visualize it because we are not meant to. It is the curtain that falls at the end of the play, and tonight we have reached that curtain. We have followed the river of gravity all the way to the sea. We have seen the birth of the whole, the horizon, the interior, the core. We have looked the monster in the eye and found that it is just a mathematical point, a period at the end of a sentence. But we cannot stay here. The singularity is a place for matter, not for travellers. If we stay too long, we will become part of the math. We need to return. We need to reverse the irreversible. We need to zoom out. We need to reclaim our separation. We need to reclaim our space. We need to go back to the world where left and right are different places, where yesterday is a memory, not a destination. So, prepare yourself. We are going to do the only thing that can defeat a black hole. We're going to use the escape velocity of the imagination. In the final chapter, we're going to rise. We're going to back away from the fire. We're going to gently float up the throat of the gravity well, past the frozen ghosts on the horizon, and back into the cool, open freedom of the stars. We're going to leave the secret room, but we'll carry the quiet of it with us. Take one last look at the centre, the point where everything becomes one. Acknowledge it, respect it, and then let go. The ascent begins in chapter 11. Let's drift to the final chapter. We have reached the final chapter of our journey into the dark. We have travelled further than any human has ever dared to go. We started in the quiet of your room. We drifted through the vastness of space. We approached the shadow. We crossed the event horizon. We fell through the twisting, shrinking tunnel of the interior, and in the last chapter we spiraled down toward the ring, toward the singularity, toward the end of time itself. But tonight, we're not going to end the story with a crash. We're not going to let the math crush us, because this is a journey of the mind, and while the laws of physics are strict, the laws of imagination are kind. In the mind, we can reverse the arrow of time, we can undo the fall. So, right now, just as we're about to touch the centre, I want you to pause, freeze the frame, see the darkness around you, see the twisting geometry, see the light of the universe behind you, shrunk to a tiny, brilliant diamond. Everything is still. You are suspended in the heartbeat of the monster. Now, take a deep breath, and let's begin the ascent. Let's rise. Imagine that your ship is made of something lighter than light. Imagine you're made of pure thought. Gravity cannot hold you anymore. The one-way signs of the interior fade away. You gently pull back on the controls, and you begin to float backward, up, away from the core. Feel the sensation of the squeeze loosening. The narrow walls of the tunnel start to widen. The pressure on your shoulders lifts. The spaghettification fades, and you feel your body returning to its normal, comfortable shape. You're expanding back into the freedom of 3 dimensions. We are rising through the dark. We are retracing our steps through the secret room. Look ahead of you. That tiny bright dot of starlight, the porthole to the universe, is getting bigger. It is growing. It is shifting colours. The harsh X-rays and ultraviolet light are softening. They are cooling, down to blue, then yellow, then white. The view of the galaxy is opening up like a flower. We're approaching the event horizon from the inside. Usually this is a wall, a ceiling you can never break through. But tonight, you pass through it like smoke. You cross the line. And suddenly, the geometry snaps back to normal. Space is no longer falling faster than light. Time is no longer pointed down. You have space back. You have left and right back. You have yesterday back. You drift out into the photon sphere. You see the light circling the hole again. But this time, you leave it behind. You climb out of the gravity well. You climb up the slope, past the steep cliffs, past the heavy tides, up into the gentle, rolling hills of the outer valley, and finally, you break the surface. You drift out into the flat, calm, open ocean of interstellar space. Stop the ship here. Turn around. Look back at the object one last time. It sits there, a perfect, silent, black circle against the stars. Looks exactly as it did when we arrived. It keeps its secrets. It doesn't look angry. It doesn't look hungry. It just looks heavy. It is a paperweight holding down the fabric of the galaxy. Now, take a moment to feel the contrast. Inside, everything was tight. Everything was focused. Everything was inevitable. Outside, everything is open. The stars are scattered far and wide. The possibilities are endless. You can go anywhere. Take a deep breath of the virtual air in your cabin. It feels lighter here. The tension of the end of time is gone. You're back in the land of plenty of time. Now, let's zoom out. Let's pull the camera back. See your tiny ship drifting away from the hole. See the hole shrinking into a dot. See the star system it lives in. Cygnus, X1. Or perhaps the centre of the Milky Way. See the great spiral arms of the galaxy glowing in the dark. Billions of stars, and among them, billions of these quiet black holes. They are the anchors of the cosmos. Without them, the galaxy might not have formed. Without the deep valleys to gather the gas, the stars might not have ignited. Without the stars, the carbon and oxygen in your body would not exist. So, do not fear the dark. The dark is the soil from which the light grows. The black hole is not a villain. It is a necessary part of the architecture that built you. Now, let's travel home. Let's drift across the light years, past the nebulas, those great clouds of purple and gold dust, past the clusters of young blue stars, past the old red giants. See our own sun, a warm, steady yellow star. See the earth, a blue marble wrapped in white clouds. See the night side of the world. See the tiny glowing lights of the cities. See your city. See your street. See your room. And here you are, lying in your bed, safe. Feel the mattress underneath you again. Think about what it is doing. It is pushing you up. It is fighting gravity for you. But think about the gravity of Earth compared to where we just were. The Earth is gentle. It creates a tiny, barely perceptible curve in space-time. It is just enough to hold the atmosphere, just enough to keep the oceans in their beds, just enough to hold you in this room. It is a cradle. It is not a trap. It is a hug. You are resting in the Goldilocks zone of gravity. Not so weak that you float away into the cold, not so strong that you are crushed into a point. Just right. You are balanced. Equilibrium. Now, let's attend to the body. You have been on a long journey. Your mind has stretched to the breaking point of physics. It is time to let the mind rest. It is time to let the geometry dissolve. Focus on your feet. Let them be heavy. Let them sink into the mattress. There are no tidal forces pulling them. They are at rest. Focus on your hands. Let them uncurl. Let them be soft. There is no squeeze. There is no spaghettification. You are perfectly shaped. Focus on your breath. Inhale slowly. Exhale slowly. Think about the time passing in the room. Tick, tick, tick. It is steady. It is rhythmic. It is not racing like it was inside the hole. It is not freezing like it was on the horizon. It is flowing at the speed of life. It is the perfect tempo for sleep. The universe is vast. It is filled with strange monsters and impossible geometries, but you don't have to solve them tonight. The black holes will be there tomorrow. The event horizons will keep their secrets for another billion years. They are patient. Your job right now is simple. Your job is to be the observer who closes their eyes. Your job is to drift into your own personal singularity, the singularity of sleep. Sleep is a lot like an event horizon, isn't it? It is a boundary we cross every night. We slip across the edge of consciousness. We leave the outside world behind. We enter a private inner world where time moves differently, where space is fluid, where the laws of logic break down into dreams, and just like a black hole, no information comes out. You disappear into the quiet, and you emerge on the other side, refreshed, reborn. So, do not be afraid to cross the line. Let yourself fall. Let the gravity of sleep pull you in. The room is dark, the house is quiet, the world is turning, the galaxy is spinning, and you are safe in the center of it all. Rest in the mystery, rest in the dark, rest in the science.